Friends, in chemistry, last part, that is a part E, question they are going to ask you, write any 3 questions. They are going to give you 6 questions. So, and they are going to ask you 2 questions from each chapter: solution, electrochemistry, chemical kinetics. Today I am going to explain you about solution. ಅಂದ್ರೆ ಸೊಲ್ಯೂಷನ್, ಎಲೆಕ್ಟ್ರೋಕೆಮಿಸ್ಟ್ರಿ, ಕೆಮಿಕಲ್ ಕೈನೆಟಿಕ್ಸ್ ಮೇಲೆ ಎರಡೆರಡು ಪ್ರಶ್ನೆಗಳನ್ನು ಕೇಳ್ತಾರೆ. ಅದರಲ್ಲಿ ನಾವು ಯಾವ್ದಾದ್ರು 3 ಉತ್ತರಿಸಬೇಕು. ಮೊದಲನೇದಾಗಿ ನಾನು ಇವತ್ತು ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಮೇಲೆ ಹೇಳ್ತೇನೆ. ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಕ್ವಾಲಿಟೇಟಿವ್ ಪ್ರಾಪರ್ಟೀಸ್ ಅಂತ ಬರುತ್ತೆ. ಆ ಕ್ವಾಲಿಟೇಟಿವ್ ಪ್ರಾಪರ್ಟೀಸ್, ದೇರ್ ಆರ್ 4 ಕ್ವಾಲಿಟೇಟಿವ್ ಪ್ರಾಪರ್ಟೀಸ್: ರಿಲೇಟಿವ್ ಲೋವರಿಂಗ್ ಆಫ್ ವೇಪರ್ ಪ್ರೆಷರ್, osmotic pressure, elevation in boiling point, depression in freezing point. Okay, first we should remember the formulas. Here they are going to ask you very simple questions. You have to remember the formulas, put the formula and substitute the values. You will get the answer. 3 marks. So first question you have to write down: vapor pressure of benzene is 200 mm of mercury when 2 gram of non-volatile solute is dissolved in 78 gram of benzene. Benzene has a vapor pressure of 195 mm of mercury, and calculate the molar mass of the solute. Here molar mass of the benzene is 78 gram per mole. So first you have to write the formula, that is P0 minus P divided by P0 equal to M1 divided by M2 into W2 divided by W1. We should know that what is the P0. P0 is the vapor pressure of pure solvent. P is the vapor pressure of solution. M1 is the molar mass of solvent. M2 is the molar mass of solute. W1 is the weight of solute. W2 weight of solvent. W1 is the weight of solvent. W2 is the weight of solute. So you can write in the question whatever they have given. Vapor pressure P0, they have given 200 mm of mercury. 200 mm of mercury, and P they have given 195 mm of mercury, and W2 weight of solute, that is 2 gram, and W1 is 78 gram, and M1 is 78 gram per mole, and M2 they have asked here. So here you have to rearrange the formula. M2 they have asked, you have to substitute the values. Very simple. P0 equal to 200, P equal to 195 divided by P0, that is 200. Here M1 value you have to substitute. They have given 78 gram divided by M2 we have to determine. So W2 weight of solute they have given 2 grams, and W1 is 78 gram. Here 78 get cancelled. Then here you have to write 200 minus 195 is 5 divided by 200 equal to, so here 2 by M2. Okay. So here we have to take M this side because we have to calculate M2, that is molecular molar mass of solute. So 2, if you bring this side, it will become 200 divided by 5. So here you can cancel 5 1 ja, 5 4 ja, this 0. So you will get M2 equal to 2 into 40, that is equal to 80 gram per mole. This is the first question. You come to know P0 minus P divided by P0 equal to M1 by M2 into W2 by W1. So what are the given we have to take down first? P0, that is the vapor pressure of pure solvent. P is the vapor pressure of solution. W2 is the weight of solute. W1 is the weight of solvent, M1 is the molar mass of solvent, M2 is the molar mass of solute. We have to determine, very simple. Here they are going to give you for formulas 1 mass, and after substitution you will get 1 mass. Last answer, that is MT equal to, this is you are going to get, you have to write here with unit, that is 1 mass. Very easy to score the mass in problems, because 3 mass 3 steps. Put the formulas, so substitute the values, simplify, so you are going to get answer, right? Okay, on next second question, here they are going to ask 1 gram of sucrose, that's molar mass is 342 gram per mole, is dissolved in 100 ml of solution at 25 degrees Celsius. Calculate the osmotic pressure. So here osmotic equal to, that is pi equal to W2RT divided by, that is M2V. Here pi is the osmotic pressure, R is the constant they are going to give you in the values, T is the temperature. Temperature you have to convert in Kelvin scale, because SI system we are using here. So M2 is the molar mass of solute, V is the volume in ml. Here given you have to write volume, they have given 100 ml. 100 ml means you have to convert in liter, that is 0.1 liter. Okay, so next W2, they have given 1 gram of solute dissolved, and temperature they have given 25 degrees Celsius. You have to convert in Kelvin, you have to add 273, that is 298 Kelvin temperature, and molar mass of solute M2 they have given 342 gram per mole, right? And you have to calculate osmotic pressure. Here pi is the osmotic pressure, W2RT divided by M2 into V, you have to substitute values. W2 1 into R value, here they have given in the question, that is R value is 0.08, they have given 0.082 into temperature 298 Kelvin divided by M2 is 342, volume 0.1 liter. So after simplification you are going to get 24.436 divided by 34.2, so you are going to get answer 0.714 atmosphere pressure. You have to write here in it. So they are going to give here formula for 1 mass, after substitution 1 mass, then last answer 1 mass. Boiling point of benzene is 353.23 Kelvin. When 1.8 gram of non-volatile solute was dissolved in 90 gram of benzene, the boiling point is raised to 354.11 Kelvin. Calculate the molar mass of the solute, that is Kb they have given value is, we have to calculate. So whatever the given in the formula, elevation in boiling point, del Tb equal to Kb into W2 into 1000 divided by M2 into W1. So in this you have to take, using this formula we are going to solve the problem. The del Tb means changed in boiling point, that is 354.11 minus 353.25, so you are going to get 0.88 Kelvin. 0.88 Kelvin. So they have given solute W2 is 1.8 gram and W1 is 90 gram and KB is constant, that is ableoscopy constant 2.53. They have given. Okay, so in here you have to substitute this del TB equal to KB into W2 into 1000 divided by M2 into W1. KB value is they have given 2.53 into W2 they have given 1.8 into 1000 divided by M2, put M2 only into W1 they have given 90 gram. So you have to rearrange this formula, you will get M2 this side 2.53 into 1.8 into 1000 divided by your del TB value you have to write here, that is B into 90. Here can write 2.53 into 1.8 into 1000. Del TB value they have given 0.88 into 90. So after simplification we are going to get 4554 divided by 79.2 equal to, so 57.5 gram per mole. So here you can write the, remember the formulas and you have to write the whatever the given values, you have to substitute, just you have to rearrange. They have asked molar mass of solute, so M2 equal to del TB will become here. So then you have to substitute, you will get the answer. So next question, depression of freezing point. So here 1 gram of non-volatile solute dissolved in 50 gram of benzene, lower the freezing point of benzene is 0.4 Kelvin. The freezing point of depression constant of benzene is 5.12 Kelvin kg per mole. Find the molecular mass of the solute. ಅಂದ್ರೆ depression in freezing point ಮೇಲೆ question ಕೇಳ್ತಾರೆ, you have to remember the formula, that is delta TF equal to KF into W2 into 1000 divided by M2 into W1. So depression freezing, Kf is a constant, they will give the value, Kf value they have given in this problem, that is equal to 5.12, that is W2 equal to 1 gram of solute they have given, and W1 is weight of solvent they have given 50 gram, and del TF means difference in freezing point they have given, del TF value is 0.4 Kelvin, right? So you have to substitute the values, just rearrange. They have asked for molecular mass of solute, so M2 equal to Kf into W2 into 1000 divided by, this will come delta Tf here into W1. Now you have to substitute the values. Kf equal to 5.12 into W2 is 1 gram into 1000 divided by delta Tf 0.4 into W1 is 50. So you have to simplify 5.12 into 1 into 1000. So you are going to get 5120 divided by 0.4 into 50, you will get 20. So after simplification you are going to get 256 gram per mole. So they are here, these qualitative properties they are going to ask one problem, to ask mole fraction. Here one question on mole fraction, that is vapor pressure of chloroform, its molecular mass is, molar mass is 119.5 gram per mole, and dichloromethane, that's molar mass is 85 gram per mole at 298 Kelvin temperature, are 200 and 415 mm of mercury respectively. Calculate the vapor pressure of the solution prepared by mixing of 25.5 gram of chloroform and 40 gram of dichloromethane at 298 Kelvin. So here in solution, first we have to take moles of chloroform, that is, they have given weight of chloroform is 25.5 gram and molar mass of chloroform is 119.5 gram. You will get that simplification 0.213 mole. 213 mole, and you have to take moles of dichloromethane, that is, they are given dichloromethane 40 gram and molar mass of dichloromethane is 85. You will get that 0.47 mole. 0.47. Total number of moles, you are going to get, that is 0.213 plus 0.47 equal to 0.683 mole. So here x1 is the mole fraction of chloroform and dichloromethane, x2 is the dichloromethane. Mole fraction of x1 equal to, that is, chloroform equal to 0. Mole of chloroform 213 divided by total number of moles, that is 0.683 equal to, ಅಂದರೆ moles of chloroform ಮೇಲೆ ಕೆಳಗಡೆ total number of moles of chloroform and dichloromethane we have to take that. After simplification you are going to get 0.312. So then mole fraction of dichloromethane, that is x2 equal to dichloromethane, that is equal to 1 minus x2 equal to, this is x1, x1 equal to 1 minus 0.312 equal to 0.688. Okay, so here total pressure there you have to calculate, that is P1 naught x1 plus P2 naught x2. So here, but we remember, but x1 equal to 1 minus x2, so P total equal to, so you can remember P1 naught plus, we know that P2 minus P1 naught into x2. So here we know that P1 naught, they are given 200 plus P1 naught, that is 415 minus 200. We know that a mole fraction of x2 is into 0.688. So simplify this one, you will get that 200 plus 415 minus 200, that you have to simplify into 47.9. So after simplification you will get 347.9 mm of mercury, that is total pressure. So like this also they are going to ask you one question. So if you solve these qualitative properties, one question they are going to ask you. Here this mole fraction they are going to ask you one question. Like this question you have to practice and able to success in the exam. Okay, thank you.